Hello everyone, I'm going through the worksheet for work and energy. This is a series of videos and I'm starting with page 1 on work done. Now question 1 requires you to understand what work done is. So which are the correct definition or which are the correct explanation of what work is. Now A cannot be correct because it says without energy work can still be done. Now remember, energy is the capacity to do work. So if you do not have energy, there is no more capacity to do work. So work cannot be done. And look at the four statements first. So for C, it says when force is exerted on an object, work will be done. Now, do take note that the formula for work done, you notice I will spell out the word work instead of writing W because I do not want to uh, get it confused with weight because weight is also W, right? So but now I'm referring to work. So in order for work to be done, F and D, none of them can be zero. So which means you must exert a force and the object must move a distance D, which is parallel to the force. So this is something you need to remember. The force and the distance must be parallel in the same direction. So C is incorrect because if the object did not move, like if you push the wall did not move, so technically you're not doing any work. And for D, of course, if you apply 1 Newton of force, object move 1 meter, then the work done is only 1 joule if you use the formula. So B is the correct statement. When 1 joule of energy is transferred, 1 joule of work is done. So to do 1 joule of work, you need 1 joule of energy. Let's carry on. For question 2, if you're doing work against gravitational force, so do note if this is the Earth, okay, the Earth will pull everything down to the middle, and that is gravitational force, right? So it's towards the middle of the Earth. So what does it mean when you say you are doing work against gravitational force? Means that you are actually moving the object in the opposite direction from gravitational force. So you are actually moving the object upwards on opposite direction, right? So that's what you mean by doing work against gravitational force. So if you look at all the options, A, B, and C, the object is moving downwards. So only for D, sorry, not downwards. This is moving downwards. The boy walking along an even road, so this is horizontal. So again, it's not up, right? The satellite, so that's moving this way around the Earth. So the only one that's correct is D, because you are lifting it up, lifting something up from the floor. Okay, so the Earth is pulling it down and you're lifting it up, so you're doing work against gravitational force. Question 3, if you want to know which one is the most work done, and so you need to calculate for all the 4 options. Now you need to note that to calculate again the formula to calculate work done, you will take force multiplied by distance. Now this force is the amount of force you apply on the object. So therefore, you find that nowhere in this equation you need to know how much the object weigh or what is the force that what is the mass of the object. You don't need to know. You only need to know how much force you're exerting on the object. So therefore, this information on the mass is not required in your calculation. So what is required is this one and this one, right? So you multiply the force with the distance, and I've actually worked it out here. You notice that the largest is A, 150 joules. So A is the answer, right? Question 4, this is the man lifting up a box. Now, you see, if you want to lift up a box, you are actually doing work against gravity. Now, this box, the earth will pull it down. So there's a gravitational force. And this is, of course, the gravitational force is also the weight. So in order for you to be able to lift it up, you need to apply a force. This force here need to be at least equals to the weight. So for example, if you're, so you have a box here. So let's say this box is 3 newtons. So if you apply 2 newtons, no, the box cannot be lifted up. You apply 2.5, cannot. You need to apply at least. Okay, so this force must be at least 3 newtons. You can apply more. You can apply 4 newtons, 5 newtons, 6 newtons. It's okay. You just end up making the box move faster. But minimally, you need to apply a force equals to 3 newtons. And if you read the question carefully, I want you to note this word minimum. So the minimum work done. Now, there's nothing to stop you from applying a force which is bigger than the weight. But since they want the minimum work done, that means you will take, so the work done is force times distance, right? And the distance is already fixed, is 1.5. And this force, since it's the minimum work done, this force has to be the minimum force that you need to apply. So therefore, it will be equals to the weight of the box. So what I have to do is I have to first of all calculate. Okay, so I'll just make it a bit neater. So I have to first of all calculate what is the weight of this box. And do note that in this chapter, you need to use this formula also quite frequently. W equals to mg. Again, I spell out the word weight because I don't want you to get confused, the W, whether it's weight or work. So W equals to mg, weight is mg. So the mass, remember, to use this formula, your mass must be in kilograms. So I convert 50 grams to kilogram by dividing by 1,000. Then I multiply by g. So again, a little bit of a recall. This g here is gravitational field strength. If the question did not give you the value, you could assume that this value is 10 newtons per kilogram on Earth. Well, these questions, you have to assume that it's on Earth, right? So multiply by 10. So now that you know the weight of the box is 0.5 newtons, so which means the Earth is pulling it down with 0.5 newtons of gravitational force. So to lift it up, minimally, you need to apply 0.5 newtons. Okay, so 0.5 multiply by the distance that the box is moved, and you get 0.75. Let's go on to question 5. In question 5, the work done is given. The distance is given. Again, do be very, very careful. You notice a lot of questions, we do not give you the unit in the correct SI unit form. So you have to be very careful and be very sensitive to the unit that the question, the quantities are in. So now it's 20 centimeters. So I convert it to meters. And then, so I know the work done, I know the distance, I can work out the force. Answer will be C, 100 newtons. Next, we go on to calculation question. Again, I want you to take note. Don't take shortcut. There are 3 steps. The first step is always to state the formula. So you can see here, I always state the formula. The second step is to show the substitution. So this is what I mean by substitution. And then the final step, your answer must be given to the correct units. And perhaps I could just add in, make sure it's 3 significant figure with no fraction. So question 1 is a straightforward question. The force is given, the distance is given, so you multiply and you get 1,007. Oh, sorry, not question 1, question 6. Question 7, also fairly straightforward, except that the distance, again, this is to ensure that you are sensitive to units. The distance is given in centimeters, so do divide it by 100 to convert to meters, and then you get your final answer, 75 joules. Let's move on. Question 8. For question 8, again, the work is given, the force is given, and to calculate the distance. So just be careful with the moving around of the numbers. You should get 15 meters. Again, take note, if the question asks for distance, your unit must be in meters. So be very careful with units. All right. Question 9. A man pushes a box and the mass of the box is 3 kilograms and you exert 10 newtons. So calculate the weight of the box. So again, weight is equal to mg. Although the gravitational field strength is not given, I can assume that you know that it is 10 newtons per kilogram. Okay, so this is something that you need to know. The G on Earth is 10 newtons per kilogram, and I'm able to calculate that it's 30 newtons. So this weight is actually acting downwards, 30 newtons. Okay, then the question says the box then move a distance of 0.2 meters. So it moved 0.2 meters, and calculate the work done on the box by the horizontal force. Now I want you to really take note. Now I'm calculating the work done by the horizontal force. Which is the horizontal force? This is the horizontal force. So if your force is acting horizontally, then the distance will have to be a horizontal one as well here. Okay, so 10 times 0.2. Now, in case you wonder why is it that 30 newtons is not used in the calculation, because the question did not mention anything about moving the box upwards, right? If you look at the question, if you look at the diagram, the 30 newtons is acting downwards. So you only need to include this in your calculation if you are talking about a vertical movement. So now we are talking about the horizontal movement. So I only focus on the horizontal force and the horizontal distance. So 10 times 0.2. And then next, this is where you have to do your calculation, your explanation. Um, they ask you to explain why is the weight which you calculated earlier, so why is the weight not taken into consideration when you are calculating the work done by the horizontal force? Now, I want you to again note this word explain. In order to get full marks for an explained question, you must ask yourself, what are the concepts that you need to support your answer? Now, they ask for calculation in part B. So what is part B calculating? Well, part B is calculating work done, right? So important thing is you should know what the topic is, and then you have to support with a statement, either a formula, a law, a principle that's related to the topic. So in this calculation of work done, then what you need to do to support your answer is to write down how you calculate work done, first of all. So over here, I've written that, so I've supported my statement here as my answer. First of all, I write down, this is how I calculate work done. So work done is the force multiplied by distance moved by the object in the direction of the force. And then I go on to explain that in this case, because the box moved horizontally, so I only need horizontal force. And then I go on to say that the weight is not needed in the calculation because the weight is acting downwards, it's not horizontally. So the key point in this question that I want you to the key learning that I want you to take away is that each time you see the word explain, ask yourself first of all, what topic is this? Can I support it by what I've learned about that topic? Okay, so in this case, it is a must for you to write down the work done. Okay, work done formula. You either write it down or you can also just explain it as a statement form. Okay, that work done is calculated by multiplying force and the distance moved in the direction of the force. It's up to you. Okay, so let's carry on. Question 10, Benjamin running up 3 flights of steps. Again, this is to test if you are careful. The question says 3 flights of steps. This is 1 flight of step. Okay, the diagram, each flight of step has dimension shown below. So this is only 1 flight of step. And because you run up the stairs, right? So how much force do you need to go vertically up? Now, the question did not say how much force the Benjamin exert, but you do know that Benjamin has a weight of 600 newtons, right? So minimally, just like what I've said in the previous question, if your weight is 600 newtons, then in order to push yourself to go up, then you need at least 600 newtons of force. So the force here is 600. And because you climb up 3 flights of steps, so that's 3. Each flight of step is 0.5 meters. Again, change this to meters, and you will get your answer, 900 joules. Some of the explanation I've written here in boxes, you can take a look. Question 11. Now, question 11 is a box being lifted from X to Y. The force that you apply is 30 newtons. The time is given and the speed is given. So this is not so straightforward because the distance is not given directly. But do recall the formula to calculate distance if you have the speed and time. So distance is speed times time. And because the speed is 5 cm per second and the time is 20 seconds. So you work out the distance is 100 cm and that would be 1 meter. So with the distance worked out, you multiply by the force, you can get the work done. For part B, calculate the gain in gravitational potential energy. If at this point of time you have not learned gravitational potential energy, then you may want to skip this question and come back to it again when your teacher has done energy. But I'm just going to continue. Okay, I'm going to assume that you have learned gravitational potential energy. This will be covered after work done. So the gain in gravitational potential energy, the formula is mgh. The mass of the object multiplied by g. G is again gravitational field strength, and h. H is the height of the object. So if the question asks for gain, that means how much GPE, how much gravitational potential energy has increased, then your height, your H here is so-called the gain in height. That means how much higher is your object. Okay, so from this distance, let's say the ground is here, object is here, and then it moved to this distance. So I'm interested in this as the height. Okay, not the absolute how far away from the ground, nope. If I want to know how much gravitational potential energy has it gained, then I only need to multiply by mg multiplied by the increase in the height. So this is x to y. I don't know whether there is a change. Wait a minute. X to y. There should be. This should be 120. Sorry, this should be 120. Oh, sorry, it's over here. The distance moved is 1 meter. Okay, sorry for the error. Yeah, the answer should be. So this is 1 meter. So this is 1 meter. Sorry. So the question says it moved 1 meter, right? So this h here is 1 meter. Okay, apologies for that. So it doesn't matter where x is. So this 20 centimeters is not important. I only need to know from x to y how much higher has the object become. So it has become 1 meter higher. So 1 meter is here. Okay. So then you calculate your GPE and the question asks, what do you notice about the two values? Well, this is that when you calculate work done is 30 joules, when you calculate gain in GPE is 30 joules. So actually the amount of work done to move from X to Y is the same as the gain in gravitational potential energy. Let's go on to calculate. Let's go on to do question 12. Okay, let's continue. This is question 12. Question 12, you might be a little overwhelmed because you see a lot of values or dimensions and so on. But let's stay focused. If the question say, so the question say that you basically push a box up. This is with a force of 15 newtons, pushing the box up, and they ask you to calculate the work done by the force in pushing the box. So what force are we talking about? The work done by this force. Okay, So we don't get distracted by the weight of the box and things like that. There will be always a lot of information that's given that's not required in the calculation. The purpose is to test whether you know how to get the only the necessary information for what you need. So therefore, in this case, with 15 newtons, because the question said the force in pushing the box, so the force in pushing the box is 15 newtons. So we got 15 here. And so this force is acting in this direction, right? So when you multiply, you will multiply by the distance moved by the box in this direction. So that would be 4.5. So 4.5. And then your final answer, 67.5 joules. Okay, so I've come to the end of the questions on work done. Do watch the other videos to do corrections for energy 1 and energy 2.